After watching that previous video, I want you to consider how the blindness did occur and to think about vocab from the lesson. So if you were to consider which parts of the brain were damaged here, okay, what would you think it is? So you should have thought about how the occipital lobe is going to be damaged from the stroke. You could potentially look at the thalamus, but the thalamus does route other senses, so we would want to be concerned with that. So in this case, like he had said, the primary visual is fine. It's the secondary reaction. It's because of the brain isn't able to integrate the knowledge or the information from the eyes. So now let's move on to the temporal lobe, which has to do with hearing. And the temporal lobe is going to be right near your ear. And this is going to process auditory information. So information is going to go from your ears to the thalamus to the temporal lobe. Now, I do have a mnemonic for this, and I want you to picture our classroom. So if you can picture our classroom, and you can think about the front of the classroom being the frontal lobe. Okay, and the front of the classroom is higher order thinking. You're planning ahead. You're learning this new higher order information, and hopefully that'll help you remember that it is executive functioning. You could also think of the teacher as the executor of the classroom. The parietal lobe then is going to be the ceiling, and I can't touch the ceiling. Okay, so the parietal lobe is going to be the ceiling, and I can't touch the ceiling. The occipital lobe is going to be the back of the classroom, and I have a hard time seeing from the back of the classroom. The temporal lobe is going to be hearing, and I want you to picture Miss Hager's room, and I can hear Miss Hager in the next room. Okay, so if you can use this method, which is called the method of loci, using that location to help us remember, think of our classroom to help remember the functions of the different lobes of the brain. Now we're going to get a little bit more in detail here, and we're going to look at the motor cortex and the somatosensory cortex. So the first part here with the motor cortex is this is the very back of the frontal lobe, and the motor cortex has to do with voluntary movement. So I want you to imagine that we take this red section and we were to take a brain and kind of cut it out and remove it. Okay, we are going to get this. Okay, this motor strip. So if I were to take that part out and move it, this is the areas that is designated to our parts of the body. So right here, the hand is located right here. So you can see how much more brain area is designated to our entire hand. The lips is located right here. This part of the motor cortex is designated to our mouth. And you can see how much bigger the hand is even than the trunk, the hip, and the leg. So what's this freaky thing over on the left-hand side? This is going to be called a homunculus. And if we were to recreate how the brain area and made it proportionate to a model, this is what our body would look like if it was how it is in the brain. And you can see it's very creepy. And I want you to consider here, why is more area dedicated to the hands and the mouth in comparison to our whole leg and torso? Okay, so if you think about that, okay, I want you to answer that question. I'm going to give you about 15 seconds to answer this question. Think about why it's more important, and then I'll go over it with you. So what you should have thought about is how our hands do, we have fine motor movement, and our hands have to do so much. They have to be able to do things that are very precise and very specific. And that is a survival mechanism. So that is why we rely on our hands are so much bigger. When we look at our mouth and tongue, think of all the different ways that we have to move our mouth and tongue in order to produce language. Okay, so that part is also going to be a lot more critical to have more area designated in the brain. So let's look at the somatosensory cortex, which again just has to do with touch. And this is located on the very front of the parietal lobe. So again, we have the homunculus for the sensory cortex. And you can see that we do have more area designated to our face and our hands in comparison to the rest of our body. Now, one thing that I want to touch on here is I had you do the nervous experiment on your last FAST assignment, and we were looking at the neurons in the fingers, the forearm, and the back. So you should have been able to feel the, in your fingertips, feel the pokes a lot closer together than the other sections. I know that didn't work out perfectly for everybody, but it's because of the neurons. But we also look at why is it more sensitive? Why are hands more sensitive than our forearm? If I get a paper cut, okay, yes, I have more sense receptors in my fingers, but I also have more area in my brain designated to my fingers than I do to my forearm. Okay, if I get a paper cut, it hurts so bad. If I were to get a paper cut on my arm, I probably wouldn't even notice. I can scratch my arm sometimes and not notice. Okay, so now what we're going to do, I don't know why I have this slide again, so I'm going to skip that. Okay, now what we're going to do is we're going to be looking at our language areas. So here it's going to be drawn, and I try to do it as closely as possible. So this first one we're going to label with a B, and it's called Broca's area. And this is going to be our expressive speech. Okay, so I'm able to produce speech and to speak because of my Broca's area. So Broca's beaks or speaks. Okay, so I will, just a way that we remember it is by saying Broca's beaks or Wernicke's wissens, which will make sense in just a bit. Okay, you could also think about how you speak with your mouth, and in Spanish, mouth is boca. Okay, so you boca with your broca. Okay, or brocas and boca. Okay, and then here, I couldn't draw Wernicke's area perfectly because I definitely don't have it proportionate here, but Wernicke's area is going to be comprehending speech. And this is going to be Wernicke's wissens, so ignore the speaks part here, that should say listens. Okay, so Wernicke's wissens. Now, what does this mean with comprehending? This is a meaning, I understand the meaning of speech. So if I were to say, raise your hand, you understand what raise your hand means. That you can understand the language that is being spoke around you. When you're producing language, you're following the rules of grammar. Okay, and I think the best way to show this is to actually show you what it looks like when it's not working properly. So we're going to watch a few videos right now. I'm going to skip this and come back to this. Okay, so here is an example of expressive aphasia. So for Sarah Scott, who is 19, not a typical person who has a stroke. Okay, so she had a stroke, and she has Broca's aphasia.
Okay, so what's your name?
Scott. Oh, no. Sarah Scott.
That's right. And how old are you?
I can't.
Try.
I can't.
Oh. You're 19. 19. Yeah. And what happened to you?
Stroke.
You had a stroke last year.
Yes.
And what happened? Can you remember what happened?
School and English class.
Okay.
And I book and I read it aloud. But I can't because stroke.
Okay, so I want to point out here with Sarah that she has expressive aphasia, meaning her Broca's area is not working. So let's take a look at this. Okay, so she has what is called aphasia. Okay, so we'll start here that it's a disorder of language, okay, and it's going to affect the person's ability to communicate. So in this case, she had a stroke, so that part of her brain is damaged or not working. So with Broca's aphasia, a person cannot speak or has a hard time speaking. So when we looked at Sarah, she was able to follow along with the conversation. So the interviewer was asking her, what happened to you? And she said, stroke, English class, read, can't, stroke. Okay, she is not able to produce exactly what she wants to say. So she can't say, I had a stroke in English class, but she knows what she's trying to say. So she understands the meaning. She understands the meaning of the question. So that would be Wernicke's aphasia if she couldn't do that. Okay, so her Broca's area is not working. So this means that she has a difficulty with producing language. So if you can think of aphasia, it means broken in this sense. So Broca's is broken, can't speak. Okay, and again, she had difficulty producing the language, but she certainly could understand and follow the conversation, and we could follow what she was saying. So let's now take a look at Wernicke's aphasia. And notice how this person has a problem understanding the meaning and the questioning.
Thanks. And say baseball player.
Okay.
Cantaloupe.
Okay. All right. I'd like for you to do some things now with your mouth. First thing I'd like for you to do is stick out your tongue.
Stick your tongue.
Great. Show me how you would kiss.
Show me how you love to kiss me.
There you
That's
go.
good.
Show me how you sip on a straw. Can you sip on a straw?
See what a sip sticks. See what a sip sticks onto me.
Okay. Try this one.
See.
Wait a minute. Listen. Show me how you smile.
Show you how plus me. Show how plus me. Show how plus me. Show how plus me.
Stop. Can you smile?
Can you smile at me?
So just for this video, you could understand or you could see how she was not able to comprehend what the interviewer was saying to her. And she also was looking at, sorry, I lost my train of thought. When she could produce all the speech that she wanted, but it wasn't making sense. She didn't have meaning in her own speech. So when we look here, we have Wernicke's aphasia. Okay, and and this means you can't listen, which is difficulty comprehending language. So the difference here with this Broca's, okay, is that Sarah could follow along with the conversation. She just couldn't say all the words that she wanted to say. With Wernicke's aphasia, patient X was able to speak as much as she wanted, but there wasn't any meaningful speech there. Okay, she also had a hard time understanding what the interviewer was even asking her. And the last thing that we're going to look at now is a structure in the brain called the corpus callosum, and this is going to connect the hemispheres. So when we look at, you can see the diagrams here. So this is like transparent, so you can see what it looks like from the angle of the left hemisphere. And then if we look straight on, you can see how these neurons, these nerves, are connecting the left and right hemispheres together so that they can communicate. The left and right hemispheres do have different functions, okay? And what we're looking at is how can we make sure that the left and right are communicating together. Okay. So with that, what you're going to do now is you're going to go and complete FAST 2.4 Part 2, okay? And then after that, I'd like you to do some independent work, and that work is going to be on Quizlet. Okay, so if you look in our Schoology folder, which I'm sorry that I don't have open, so just give me a second to do this. So in our Schoology folder, because we have a quiz next unit, okay, next class period, I have our Quizlet information in here, and this is broken down by kind of subtopic. So you could look at neurotransmission. I would like you to look at the brain because that's what we did today. So this would be an excellent review for all the material today. But then you can take a look at some of these other topics like neurotransmission and the nervous and endocrine system. Drugs and addiction we're actually going to wait on because I rearranged the units this time. Okay, with that, if you have any questions, please don't hesitate to email me and take care.